Yes.
Yes. Yep. Okay. So I think so. Should we dive into? Hanno said he would love to dive into monadic bind, and I think that's cool. But like, let's do it in terms of maybes and eithers. So we haven't really played with these things. I'm sure, like you guys, in some scenarios, you've encountered the maybe or the either data structure, and they're actually really simple to think about. They're really cool because those structures are conditional type of ones. So for me, they speak to control flow. You know, like an if statement. If I execute this function and it works, do the following. If it fails, do something else, right? That's what the maybe data type and the either data type, are really around sort of like allowing you to structure your code in terms of these like conditional things. The other really so from a data perspective, they're actually quite simple. But what's really cool about them is they are themselves also monads, and they have a whole lot of interesting type classes associated with them, which allows us to use them in like very interesting ways, like to literally replace stuff like if statements using these data structures. So maybe it sounds like a bit batty, but let's see if we can understand. And it's actually like very easy to understand. So this is what I think we were doing. And you folks must interrupt me if like anything's unclear, because I know Kieran specifically, this is new-ish to you. So I'm like happy to clarify stuff as we go. I think my camera is slowly falling down. So I'm going to keep adjusting it maybe. Okay, there we go. So, so we were talking about void last week. So void is this thing where we've got string to void. So this is a function that cannot be implemented because this function, no one can ever return a void. So you can't implement this function. If void was on this side, if it was a void function returning a string, this would be a function that could never be executed because nobody could ever construct us a void, right? So there's a good reminder. Isn't that a cool thing? Void and unit. Oh, so cool. You have to remember it. Okay, so here's either. Let's start with maybe. Maybe is the simpler guy. Either is just like a tiny little power up on either. So maybe is this data type that actually is like super simple. We can in fact write it ourselves. We can say data maybe. So maybe holds something, like it holds a type. So when you construct a maybe, it has to be typed. And so that's what this little a is. Any lowercase letter here is like the type. It could be T if you want it to be. And then when you're building, so this is an ADT, an algebraic data type, right? So this is that thing where you've got to provide it constructors to. How do we construct a maybe of type T? So what type of maybe T or something, or maybe specialized on type T? We would say equals, and we'd say, so the maybe I can see the way PureScript does it is they have a nothing constructor. So nothing takes like nothing over here. So you can see it's like it takes no parameter to construct a maybe of type T, or it has a just of type T. Does that make sense? I'm going to make this A because that's just better. So like given that definition of maybe, and you can see I'm actually not including data.maybe in my imports here. So this is cool. Like I've created my own maybe. Maybe I should rename it so it doesn't clash with the other maybe. It could be that maybe does get pulled in through the prelude. It probably does actually. So let's just see if this even compiles. It seems to compile. Spago build. Yeah, it's happy. So yeah, so data maybe is not actually included by the prelude. I do think if I imported it, import data.maybe, and I imported the whole thing, can I do that? No. Let's just import the entire thingy. It says it's redundant. All good. It is imported by the prelude. Anyway, okay, so how would I use data? How would I use maybe? It's very easy. So like maybe in my, I can just create a thing like x equals just 5 or something. So I'm calling that constructor and I'm passing a value of a, which is 5, which we all know is like an int. So PureScript at this point will probably give me a warning saying it doesn't know what it is, but it's inferred it to be a maybe int. Does that make sense? So it kind of knew that, oh, this is a 5, so that's an int. So the compiler's inferred this thing to be a maybe of type int. Happy with that? The warning is here because I think my linter says you must always give these things types at the top level. Yeah, but I don't have to, and it's just a warning, right? You guys comfortable with that? So we know how maybe works. We just create a, I've called that constructor. I've provided a value of type A. It could be of anything. So it could be a just of hello. And now as soon as I save that, this thing becomes a maybe of type string. Yeah. Or it could be a just of 1.5. And this thing becomes a maybe of type number. So number you can see is like that kind of decimal, like a float or a double or whatever. Does that kind of make sense? So you can see the compiler being quite clever here and inferring types. Any questions around that? No? So I suppose I could also make a like a y, and I could say, oh, this is of type nothing, right? Does that make sense? So a nothing, interestingly though, is like, well, what type is it? Because we haven't specified, the compiler is going to struggle to infer the type of y. And it's probably, for now, it's saying, oh, the inferred type was a maybe T1. It's like it's deferred it. It said like, I don't know what type it is yet, but it's definitely a maybe type. But the type that maybe carries around is unknown at this stage because you've given me no other hint as to what this thing is. Do you know what I mean? But it's still okay. It's a warning. I haven't used Y yet, so there's nothing for it to type check. It's going, yeah, it's at the leaf of the type checker. You've not used it. I'm not going to force you to give it a type. If I had actually said it's of type maybe int, that warning would disappear, and now Y would be absolutely of type maybe int. I mean, as I've been explicit there. So nothing is an interesting one because nothing doesn't provide one of those values. So the compiler can't use it to infer that its type. Does that make sense? So nothing is this unknown. I mean, from a type check perspective, though. So say I created a function and I said, hey, function takes a whatever, let's see, a t or something, no, not a t, an o, and we say, oh, so sorry, let's take a function which takes a maybe of type int and returns us a unit. So this function does nothing. F of o equals unit. So so that's cool. Does that make sense? I've made a function that takes a maybe of int and returns us a unit, f of o. If I've got y here and y is of type nothing and we don't know what it is, it's a maybe of t1. If I call f with y, and let's make a z equal to f of y, y probably can now, oh yeah, so let's just say z is a unit, as we know. Do we have any issues here? It should, at this point, I think the compiler would go, oh yeah, because like when you call f, it requires a maybe int, and so the y there should be now a maybe int. So if I had to make this a maybe string, that would be a problem, right? A string with int doesn't work. Maybe int is like happy, and if I leave it out and let it infer it, the compiler is definitely inferring maybe int. I mean, we know that, right? We can see that. Agreed? It's still saying that it's inferring a maybe t. I don't know. But like, does that kind of make sense? Like the compiler's type, the type checking, there's no errors here around that stuff. There's just warnings around inferences of those types. Does that kind of make sense? So it's like you can defer inference of types to like usage. So where this thing is used, the compiler can infer types from that, which can be a little bit surprising because that's not often in most other languages. The inference happens right now, whereas this compiler and the Haskell compiler will defer the inference of the type until its usage. It's actually quite similar to how I think C++ and templates work a lot like this. So the template will only be created and stamped out once it's used. So often you'll get these weird delayed errors. Like you get no errors while you're coding up your maybe type, but then later on when someone uses it, there's an error, and it's like, oh, it's because now the compiler's actually finished the inference, if that makes sense. Yeah? Any questions around that stuff? All make sense? Sort of?
I think from my side, yeah, I'm curious
Kevin's
on
nodding.
the usage It's like when you get it as a return type.
Yeah.
You
Yeah.
need
Yeah.
to make the, yeah.
Yeah. So let's go with it. So let's go with our X here. So we've got a just of 5 or something, right? So there's our X. So now, so like, how does this, like, how do we now use this X of 5, or this just of 5? Sorry, does that make sense? How is it used? And it's like it's pattern matching. Like, we have to pattern match it. So we would say, so say we want to do something with it. Like, if it's a just, if it's a like we want to add 5 or add 10 to the value inside that maybe, right? We would go like z equals, and then it's like, well, now we have to pattern match it, because X could be one of two cases, right? X could be a nothing, or it could be a just. So we have to like unwrap it out of its wrapping, right? So we would go case X of, which is the pattern matchy thing. I don't know how best to format it, maybe like this. And we would say, well, if X is just of whatever, X prime, then do something. Then it's like, well, then what is Z? So then Z is X prime plus 10 is what we wanted to say, right? So we wanted to add 10 to whatever's inside the just. Interestingly, now it's like, well, what if it's a nothing? What do we do? And like, well, that's a very good question. It's like, absolutely, because we are saying that this is a maybe int. It's not always an int. It's sometimes an int. So you do have to handle the case where it's not an int, where it's not an int. Well, it's not a value of an int. And like, well, here we're doing it. So we have to go like, okay, well, what is it actually? So maybe the answer is naught or something. I don't know. It still has to be like what we give back. Z still has to be of some type. So here we're saying Z is an int, because we can see that it's an int in that scenario. It still has to remain an int in this scenario as well. You can't, like, the type of Z can't change to like something else, right? In the middle of stuff, because it will be like, well, now Z is sometimes a string and sometimes an int. Like, that can't be. It can only be of one type. So it's like, okay, well, what is it? It's a 0, maybe. I don't know. Like, whatever's meaningful, minus 10. I don't know. Does that kind of make sense? So that's how I would use maybe. Like, very naively, this is probably not the right way to use it, but this is certainly one way to use it. Yeah, I mean, like, what you would mostly do in this scenario is you would say, like, if Z was going to add 10 to the number under a maybe int, he would himself probably also be a maybe int. Does that make sense? And when X is actually an integer, then the answer for Z is he is just that number plus 10. And when X is nothing, probably Z is also nothing. Do you know what I mean? So in that way, what we're doing is we're carrying the idea of maybe through. So if I said to you, because otherwise you're kind of like lossy, you're like throwing away information. If you're saying, oh, when X is nothing, then I'm going to return you naught, it's like, okay, so you're just throwing away the fact that it was nothing, because naught could also be a valid answer. If you had minus 10 and plus 10, that would also end up as being naught, right? So it would be kind of like, it's kind of lossy. So the way to make it not lossy is kind of carry the maybe. You know what I mean? So maybe this function's badly named, but let's call it like add 10 or something to some. So given a maybe int, I will give you back. So here's the first scenario. Given a maybe int, I'll give you back an int. Add 10 to X. That makes sense. And here's our previous version where we said something like that. Oh, name X was shadowed. Oh, because that is X. Sucks. Let's call it A. Yeah. Does that kind of make sense? So from a function perspective, if you want to add 10 to a maybe int, like, does it always make sense to collapse it into an actual int? I would say, like, the best solution here is not to do it like that, but to say, if you give me a value that's a nothing, I'm going to give you back a nothing, because that kind of makes sense also. You know what I mean? We're going to continue that game. And so it would be implemented like just and nothing. Oh, sorry, this thingy might confuse you. It's really just a bracket to the end of the line. So it's like a just of that answer. If I leave out these brackets, just ends up taking a few parameters. So it's like So this thing is like, I don't know what it's called, like left associative, and it's a very hard bind. So just eats that and that and that, like too many things. So we've got to bracket it like that, or the dollar is the fancier way to do it. Happy with that, Miguel? Any of that make sense?
Yeah, I'm following so far. Sounds like it's as well similar to, well, no, not similar, but carrying it down is like if you make something async, you go async all the way. So the practice would be
Yes.
if you make something maybe, keep the maybe
Yes.
all the way. I
Yes, exactly.
think that's more like a general rule, but not like the guiding principle. If that
Yeah.
makes sense.
Yeah. I think that that's just good practice. But it may not always be the case. Sometimes you want to force it to an int. And maybe a better way to do that would be like also given an int, which is like a default value. I'll give you back an int. So it would be x with a default. And so when I call this, I'll give you back x plus 10. Otherwise, if it fails, I'll give you back the default. So now when you call add 10, you can say z equals add 10 of 2a, which is our just 5. So actually, let's just do it just 5 right there. And it's like, what's the default value? 0, please. Do you know what I mean? So that might be like a friendlier, more explicit way of doing it, other than like surprising a dude with like just some random 0 or something. I don't know. I mean, it's up to you, right? Okay, so that's as simple as maybe is. So maybe is really, I would say, like similar to like nullable, right? So like the concept of null, there's like an absence of value. That's what really maybe wraps up. Let's see if we can do something cool with it though. So that my crappy little, actually I'll keep it. That crappy little function is pretty crappy, and we can definitely do this better. Let's keep that as a maybe int with a just there, and this thing keeps the nothing. Yeah, something like that. This almost, I think I can get this directly. This kind of behavior of applying some function, because if you think about what's happening in this just case, so when x is a just of a value, really all we're doing is we're just saying, oh yeah, in the case where it's a just, please will you just apply this function to that element and rewrap it back in. Like I actually haven't really changed the data types. I've gone from a maybe int to a maybe int, and all I've done is I've just wanted to manipulate the thing under there, the int underneath the maybe. Where it's a nothing, I don't care, but it still remains a maybe int. Do you know what I mean? So where it's a nothing, it's always a nothing. Where it's a just, I just want to apply this function to the element under the just. Does that make sense? So I'm pretty sure I can do this, use it without having to write a whole function with a big case match. I'm pretty sure I can do this like, let's see how we could do it. We can say take A and effectively apply like plus 10 to it, something like that. I don't know how to apply plus 10. So let's say apply this function E, and given the E plus the 10 of that thing, oh, I may need to say, do I need to say just here? Possibly. Something like this, maybe. I have to just that. Sorry, what is A? Oh, it wants the function first, maybe. And this is just getting to like crazy stuff here, but I will reduce it if it works. No, I'm wrong. Okay, so let's look at maybe. So, oh, we could use the Functor instance of it. Yeah, okay, so maybe that's a good start actually. So we talked about Functor is this ability to call map on stuff, right? We can, if we had a list of A's or a list of ints, we could map that list of ints and convert it into a list of strings or something, right? So it's like a way of mapping over a collection. But Functor is actually, it's a higher level thing than that. It can really map over anything which implements the Functor type class, of which maybe does. So maybe does implement Functor, which is really cool. So that means I could take my A and I could map it. So I could go map of A with, and then it's like, well, what function do you want to apply to every element of this thing? We know that there's either 0 or 1 element, right? So 0 in the nothing case and 1 in the just case. So here's our, and this is like an inline function. This backslash tells you this is the start of a function. We don't actually need the brackets. So backslash is meant to look like a little lambda character, and E being the one of the parameters. If there was 2 parameters, it would be E and F next to space like that, and then a little arrow, and we would say, oh, it's E plus 10, something like that. What's our issue here? A is a maybe int. Yes, we know that. You guys see any issues here? Oh, you know what? Map, I think, takes the function first. Am I right?
Tom, what's the chances we've like shadowed the default maybe?
Oh yeah. It's probably a good point. Yeah, probably a good point. Data dot maybe, and we want maybe, and we want all of its constructors. Yeah, that was it. Well done, Miguel. Because our maybe doesn't implement the Functor interface. So like, let's see what, so Z, actually we know what it is. Z is of type maybe int, right? There we go. So what we've said is like, okay, so A is a maybe int. We know that actually it's a just of 5. That's fine. But from a type check perspective, it's a maybe int. And we've said, oh yeah, please use map, which is provided to us from Functor. So let me click through to Functor. So Functor provides us with a function called map. Map takes a mapping function from an A to a B. Given an f of A, which is a maybe int, I will give you back a maybe int. So we went from an int to an int. A maybe int to a maybe int is how map ended up resolving itself. Does that make sense? Like, there's some mental gymnastics there. But wherever we see these lowercase letters, and like this one is a specifically interesting one because it's like a something of a something. So this could be a list of int, or a maybe of int, or an anything of one type. Does that make sense? It could be an array of string. It doesn't matter. As long as it's like something space something. So it can't be an int. This is not an int, because int is only a single, so it's called a kind. It's like, it's a what would you call it? Like a singleton kind. Int only has, like, when you construct an int, you just give it a value, boom, 5. There's only one value that it requires to construct it. Whereas a maybe int requires 2 things. It needs a just and a 5, or it needs a nothing, right? So it's like from a type perspective, it's got 2 parts to it. Does that make sense? So wherever you see like F space A, like they're using the word F here because we're in Functor of type F. But that could be an M if it was a monad. It could be a B. It doesn't matter. It's just a something of something. Does that make sense? It may not make sense until you kind of get used to it and you start to, like, in your mind, start replacing those things as you go. But anyway, there we've just used Functor provided to us by maybe in order to map the value under the maybe A there. So like, I didn't need to use, I could have said just 5 maybe. So Z is a maybe int. Please run that function against that value. Any questions here? Is it obvious? Not obvious.
Tom, I think it makes sense to me. What is maybe missing is, where is it doing that check whether it's a just or a nothing?
Oh yeah, exactly. Good question. So here's how it, so then we must look at the instance of Functor maybe, right? So let's go to the source code of this, because here they show you. So where is map implemented? There, Functor maybe. So like, if we just read how they implemented, it will be very obvious to us. So we can see, here's the function. So map is how we're calling it. We're giving it a function, which is the element plus 10. Okay, so that's what fn is. And they're pattern matching it. So they're saying, oh, when it's a just of x, return a just of that function applied to x. Does that make sense? Where it's
Yeah.
a map of anything else, so probably nothing or something, yeah, it would be the only thing left, which is nothing. It's like, oh, then the answer is nothing. That's their implementation. So we must know that when we map this thing to just 5, this function will be executed. So it will be, oh, e plus 10. So 15 it'll be a just 15. If we provide nothing here, the result will be nothing. Z will be nothing. Because we can see it will happen here. So nothing, it will hit that pattern, and the answer will be nothing. It's like that simple, actually. So we can see the logic of how the person who wrote maybe interpreted this. They said nothing applied to any function is like it's always nothing. Don't even run the function. The function doesn't even get executed. The function only gets executed where you provide me with a just of a value. I'll execute that function against that value and return a just of that result. So it's like it wraps it back into a maybe up back for you. And I'd say, yeah, that makes sense. So wherever it's nothing, the answer is nothing. Is that clear, Matt?
Yeah. Yeah. Makes sense.
Is that clear to anyone else?
Based on the other stuff we've gone through, it makes sense. The pattern matching.
Yeah. So it's like, so maybe has it got a very opinionated way of how it is a functor. So it's a functor, and its implementation is obvious. You can go and look at its implementation. That may not be what you want, because maybe you did want to return just of naught or something. Then it's like, oh, don't use this functor. This functor, actually, like their documentation is quite good. So the functor instance allows functions to transform the contents of a just with the dollar operator. Okay, good. So function applied to a just of x equals a just a function of x. So this is not really code. That's more telling you what the result would be. And then it says nothing values are left untouched. So anything provided with a nothing, any function, nothing, any function applied to nothing is nothing. Like guaranteed that function does not get executed. Yeah. So that's maybe one way. And we know that functor, actually that is the functor operator. So we know we didn't have to use map here. We could have gone like that. We could have used that cool little operator. It's exactly the same. So I think you guys have seen that, right? In functor, we saw that here's the map function, but there is an operator called dollar or bracketed dollar, which is an alias for map. There's a reverse version of it, which is like with the hash. So we could go, it depends on like what you felt like writing here. It was maybe that way around, like more pipeline mode or regular. Happy with that? Sort of.
Is there a built-in function, I'm assuming, then to as well unwrapper maybe?
Yes. Good question. Yes, exactly. So let's keep going. So there's functor, and interestingly for Hano, I'm pretty sure there is a bind of maybe. Yes, there is. And it would be, I would say, very similar to map, right? So a just of x bound to a function gives us a function of x. Oh yeah, so it would f of x. Oh, we'd have to pass. The only difference would be so let's play with bind quickly before this is just for Hano. Everyone else close their ears. So if we wanted to bind, do the same thing, like z prime equals nothing. So we wanted to now bind our function, this one. I don't know if that would just work. I don't think it would. Yeah, because what it wants your function here to do, does any of this make sense to you? I know. So maybe we want the same thing, but we want to use bind. How is it different to map? I think the difference is that bind must always maintain the context. So the answer should be just e plus 10. Does that make sense?
Yeah, they just put the onus of wrapping it again on
Yes.
you instead of it happening automatically.
Yes, because normally with a with like bind, you should call, like in Haskell, you would say return this thing. It would also work if we said pure. Yeah. So pure in PureScript is the same as return in Haskell, which is to like just take an element and wrap and stick it straight into the context. So pure, like if you see what pure does, if I can move my mouse up, pure takes an A and gives us back an F of A. So it takes that int and wraps it up into a maybe int. We could have just said just as well, but I'm pretty sure that the implementation of pure for maybe is probably just. It probably goes pure equals just. I can almost guarantee it. But that's the difference between bind. And the idea of bind is that we can just continuously bind this thing over and over and over, right? Whereas with, yeah, I think that's
that might be useful if you have a scenario where you want to maybe divide by x, and there may be a scenario in the function where you could return a nothing.
yes,
It won't be just by default.
yes, exactly. Yes, exactly right. Yeah. So I can have more control flow through this thing. Yeah. I think so it's totally bindable. I think it's maybe more interesting in the either scenario where you've got like two paths. So if you think about maybe sort of short circuits, and you can see how it short circuits in map. I wonder if in bind it also short circuits. I think it does. I think it will short circuit because it goes nothing bound to F is just nothing. Whereas with either, I can't remember. I think maybe it also short circuits. I don't know. So wait a minute. Back to Miguel's question. Oh, it was like, is there a function? What was your question again, Miguel?
To unwrap the maybe.
Yes, to unwrap it. Yeah. Yes, and I think it's a function called maybe with a lowercase m. So let's have a look at what so maybe provides us a whole bunch of extra cool functions like maybe prime, a from maybe prime, and like look what they do. So let's actually start from maybe. I think this is the one I use primarily. So it takes a default value and a maybe value. If the maybe value is nothing, the default value is returned. Otherwise, the value inside the just is returned. Does that make sense? So we've got from maybe. So we could go, so say we want to log this thing. No, it doesn't matter. Let's just make a new thing. Z is an int. So like now we want the value of whatever this z is, and we know z is a maybe int, so we actually want its value. We could use from maybe, so we could say, well, z equals from maybe, and we provide it with a default value. So we say, oh, okay, if it's a nothing, give us a minus 55 of z or something. Multiple exist. Yes, have I already created a z prime? Oh, sorry, not equals, of type int. From maybe needs to be imported. From maybe minus 55. I think this minus is problematic. Yeah, I think you have to. I think Bhavesh knows this. You have to bracket negative minus because like minus is like a function or some. I don't know. I'm not 100% sure why I have to bracket it, but you do. So here you can see now we're unwrapping it, right? I mean, this is what we're doing. Right? You agree, Miguel? We're unwrapping z, which was a maybe int, using from maybe, where it's a nothing, give us minus 55, and where it's not, give us the value underneath it.
Yeah, that makes sense. My head, it looks like what some of the link functions do with like first or default, or like, so either give me the value or give me a default. Okay.
Exactly. So let's log this thing. So I'm going to log it with a show. So I think we looked at show a little bit. Show is another type class which will convert anything into a string. So assuming that there's an implementation of show for your type, from anything to string. So I'm going from int to string. I've got an int. and I'm going to go to string. And so, like, fortunately, someone has already provided us that implementation, so that's cool. So here you can see, oh yeah, so Z is a nothing, which we mapped, so we know that it's a nothing. If this was a just of 10 or something, and we ran that, it is now 20. So I should have said just 5. Do you agree? So from maybe is pretty cool. It's like unwrap it and deal with the nothing, because it has to force it back into one type. There are other cool functions, like maybe I think is potentially more powerful. So I think, what does maybe do? It takes a default value, a function, and a maybe value. If the maybe value is nothing, the default value is returned. Otherwise, the function is applied to the value inside the just, and the result is returned. So it's pretty much the same as from maybe, except except we pass it a function as well. So when it's a just of something, it'll run that function with that just of that thing, giving us back the b. So you give a default value, a function giving you back a value, the actual maybe of itself, and it will give you back the value, either the default or the result of your function. Does that make sense? It's a bit of a, like, maybe probably less useful, but more powerful when you need it. Maybe prime looks like, oh, it's a unit giving you that thing. I don't know why you'd want that. From maybe is just. So there are ways of also saying, hey, is this thing a just value? So given a maybe a, it will tell you true or false. Is it nothing, true or false? From just. Oh, so this is interesting. There's this thing called partial. I don't think we want to dive into it, but this will create a runtime issue. So if this thing, so this is basically a dangerous version of from just. You're saying, oh, this thing is guaranteed a just. Like, give me back the thing inside there. I'm not going to give you a default value. It is always a just. And it's like, well, if it isn't, your program crashes. So that should be called unsafe from just, right? So you can see, like, there's definitely escape hatches where you want to break the type system. Does that make sense? So I think we've killed maybe. Have we killed maybe? The other cool data type that I like a lot is either. So either is like maybe, but slightly better. So if you look at its definition, either takes two type parameters. Isn't this interesting? So it takes an A and a B, and it's got two constructors, a left taking the A and a right taking the B. So you can imagine it's like a tree or something. It's like you've got left sides and right sides. The word left and right are a little bit loaded. So I think this doc will tell you, yeah, a common use case for either is error handling, where left is used to carry an error and right is used to carry a success value. And so even though they look like they could be balanced, and you might say, oh, lefts are actually successes and rights are errors, or two different paths, the way they are implemented in terms of functors or something, it could be quite opinionated about what is left and what is right and what to do with them. So with so let's just use an either quickly. They're pretty simple. So we might say A is an either, and then you provide it its left side. So if it's an error, what should it be? Like maybe a string. Maybe the string carries an error, and on its right side, maybe it's an int. Do you know what I mean? And we can say, oh, okay, so A is a left of this is an error here, like, or something didn't work. Something broke. Probably have to import this thing, data.either, and we want all the constructors of either. Yep. So A is an either of string on int, and we've constructed it with left. Looks a bit wacky. B could also be an either of string and int, and B is a right of 10. So it's like, oh, look, they're of the same type. Sometimes it carries a string, sometimes it carries an int. Does that make sense? And then it's like we can do the same stuff. So we can map this thing. So we can say Z equals A. Let's use our cool mapping function. So if I get an element, I want to take that element and add 10 to it. Perfect. So Z is now also an either of string or int. Agree? So we took A and we mapped it. It's a bit wacky though, because like a doesn't have a value. So we kind of can see already here that it's like this function is not going to work, right? It's not going to run. It is going to work. The compiler is happy, but pretty much we can see the implementation of Functor probably for left is just left. There's no execution of the function for the element. So this map function will only apply itself to right constructed paths. Does that make sense? Yeah, because I'm pretty sure if I took Z and I show it down there, and that's very cool. I've got a show instance for either string int. How cool is that? And we will see that it is left something broke. So we can't just map +1 +10. If this was B, it should be right with 20. Yeah. Mind bending, not mind bending. Karen's looking confused. Do you not deal with these kinds of problems in your usual day-to-day life?
Yeah, I can't say that I do.
So it's a very powerful type. So if you look at either, like this type, either string int, is really, really cool. I mean, it's like, it carries around all the information for what this thing is. You know what I mean? It's got these two potential branches to it. And from a calling, like the way I use it is like very odd. I just say, oh yeah, take it and map it to this other value. And I know that left will always be handled. So I could continuously map these things. Do you know what I mean? I could map it to another E with E -2 or something, right? I can continuously chain these mappings on. And I know that I'll have no problems. So because left will just, it'll short circuit right there, and this won't be executed if this thing is a left. Like the mapping just will resolve as left, 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 left. And when it's right, it will bubble and be correct. So it's quite an explicit way of handling errors. Like this is very much a good, I mean, this could be like your either could be a database connection. Like I connect to the database, like I've got a function connect, and it returns an either of an error or a database connection. And then I just take that structure, which has got the captured error in it, and I just say, oh, cool. So take that thing and just apply insert statements to it. And if the database connection string is an error, like it just won't invoke it. If it is connected, it will invoke it. You know what I mean? It's like, and what it returns back is like that same captured state. So that state just continues and continues. You pass it down everywhere, and it'll all just kind of work. You know what I mean? Which is really cool. So it's like the error just is passed through the whole program. It's like woven in. You weave your error state through your whole program. But then you do need cool functions like this mappy one in order to do stuff. I think what's interesting about either is maybe bind could be more interesting, or maybe not actually. I don't know. So bind is now, yeah, you can actually see it automatically is a left. So this is short circuit. I think maybe we must talk about bind in our next thingy, because so already you can see here, like this becomes a little bit difficult to understand, right? We've got like a something, and then it like invokes this thing, and then it invokes this thing. And it's like, okay, I mean, maybe this does look okay, but it's pretty tricky to read. And there could be like much more complicated things going on in here. And so really what bind does is it allows you to create a notation which looks like, I wonder if we could do it quickly. So it allows us to use this notation called do, where we go, oh, do, and we say, oh, let's go, I don't know, I've always got to think of letters. Sorry, I should use this funny little back arrow thing, and I go like this. I say, so, oh, what would I do? Not quite this. I unwrap it. Yeah, so I take A. A is an either string of int, and I unwrap it as C, yeah, and then I can go C plus 10 or something like that. Would I go do? I would have to go pure C plus 10. Yeah. So what this is doing, this do notations is it's just syntactic sugar really for that previous kind of like bindy type code, and it's saying like almost create a new value called C in the world, but only on the right side, only on the success case. If this was a maybe, it would only be the just. If it was a nothing, this function would just return at this point. If it continues, this is the answer, and we can have multiple of these things. So we could say, okay, so C equals. So maybe here's a good example. Yeah. Okay. So we go. Let's actually use A prime. So we'll use A prime is from A, and B prime is from B, because remember we got B there, and then I want to add them together. A prime plus B prime. Forget this little pure bit. That's just a little bit of implementation issue. But here we've got a Z, which will add the two ints together over there, giving us back a result from A, but only if they're right. If they're left, it's the string error. It's the left. It will be the first one. It'll be that one's error. So it's almost a way of rewriting the way we had it, which was like, how would we rewrite this? We would go like case A of right of A prime, then case B of right of B prime, A prime plus B prime. Does that make sense? And we can rewrite it as this like cool do notation. That's what bind allows you to do, is rewrite stuff in this do notation. So it kind of looks imperative. It looks like it's a multi-step function, but it gets compiled up in terms of this operator bind. Pretty tricky though. That is a little bit tricky. I don't expect you to understand that. Not just yet.
Sorry, this is a dumb question.
Yeah.
But what would happen if you want to process the left of one of those, of let's say A prime, and the right of B prime, or handle some case where they both aren't right? I don't know if that makes sense.
Yes. Then you would need to write it out yourself, Terence. So you wouldn't, because I'm pretty sure that Functor and bind are opinionated. They kind of only continue along right side values. So if you wanted to, like if you had two lefts and you wanted to concatenate the two strings together or something, you would have to write your own function to do it, which would maybe be like this, you know. So like T given a either string and int, and an either string and int, giving me back an either, maybe like giving me back, yeah, an either string or int, right? So giving two of those things, like left side, let's go A and B, you would go like, so maybe if it was left of A and left of B, those would both be strings. I would want to return a left of A concatenated with B or something like that, right? Anything else, T of anything else, and I'm just going to be naughty here, is just right of 10, something, right? I'm not telling you what to do when they're thingied. I'm shadowing here again. AA and BB. Always have to come up with new TLAs. Yeah, does that kind of make sense? So it's like, oh, I can write a function that does that. So if they were both lefts, A would be a string and BB would be a string, then the answer is a left with those two strings concatenated. If it's anything else, give me back a right of 10. Something like that. We're out of time, guys. Any last minute stuff?
So I have just a quick question on the case. Can we do a case with multiple inputs?
Yeah. Yeah, totally. Yeah, absolutely. I mean, you've got you can do it in various ways. There's even a tuple type, so you can just case match on a tuple. That's another option. But I'm pretty sure you can go like case A, comma B of, and then it's like just of L, comma just of X. You know what I mean? So like a pattern match like that. If that's not possible, you could say case of tuple. Well, I think it's MK tuple, I can't remember. And then you just unwrap the tuple there. You know what I mean? So you can absolutely have a case match which is like got loads of shit loaded into it. I could be getting confused with Elm here with this automatic tuple action. I can't remember. But I think you can, yeah, because this is effectively like a record type of thing, is it? Something like that. But yeah, you can totally. Yeah, you'd have to make sure that you're exhaustive though, of course. So like the compiler would check for exhaustion of statements, of cases.
That's very cool.
Yeah. But quite often, I would say you don't often have to do that. I suppose no. Yeah, you do quite often want to do that kind of thing. Yeah. It's power. Okay, I gotta go, guys. Speak to you later. Thanks,
Cool.
dudes.
Thanks.
Have a great
Thanks,
week.
Tom.
Bye.
Cheers.